Dear students, let's continue our practice on mathematical analysis 1. The next topic is functions, domain and range of the functions. So first, what exactly is function? Let's give a definition to function. The simple definition is an equation will be a function if for any x in the domain of the equation, the domain is all the x's that can be plugged into the equation. The equation will yield exactly one value of y when we evaluate the equation at a specific x. This is usually easier to understand with an example. Example number 1. Determine if each of the following are functions. So here we have solutions for A1. This is first, it is a function. Given an x, there is only one way to square it. For example, if you put 2, it will be 4. If you put 5, it will be 25, and etc. And add 1 them. So here, no matter what value of x you put into the equation, there is only one possible value of y. For example, if you put 5, so we have 5 squared plus 1, 26. For any x, we have the exactly one possible value of y. Now, the next one, b1. The only difference between this equation and the first is that we move the exponents of the x and onto the y. So we have y squared x plus y. This is small change is all that is required in this case to change the equation from a function to something that is not a function. Why? Because to see that this is not a function is fairly simple. Choose a value of x, any value. For example, x is 3, and plug this into the equation. So what we have, y squared is equal to 3 plus 1. It's equal to 4. Now, there are two possible values of y. The first one is 2. The second one is minus 2. So, it's not satisfied our definition. So, it should be exactly one value of y when we evaluate the equation at a specific of x. So in this case, it's not satisfied. That's why it is not a function. Note that this only needs to be case for a single value of x to make an equation, not be a function. For instance, we could have used x is 1 minus 1, and in this case, we would get a single y. So if we put minus 1, we have minus 1 plus 1, it is 0. However, because of what happens at x is 3, this equation will not be a function. So we could have used x is minus 1. Okay, example number 2. Given function f of x, find each of the following. So what it means? It means just we should put instead of x exactly values of x. A1, f2. It means instead of x we should put 2. So answer is minus 3. B1. So instead of 10 we should put minus 10. So the answer is minus 171. C1. We have t, f of t. It means just we should change our x with t. So now we have the equation of t minus t squared plus 6t minus 11. The next one, d1, t minus 3. So we should just change our x's from x's to t minus 3. So the answer of our equation is as minus t minus 3 squared plus 6t minus 3 minus 11. Or after simplifying of our expression, we have minus t squared plus 12t minus 38. Example number 3. Determine all roots of f of t where equal to 9t cubed minus 80t squared plus 6t. Solution. So what we should do, we should solve our equation, cubic equation. Firstly, we should factor this equation. So we can take out the brackets 3t 3t squared minus 6t plus 2 in the brackets, inside of the brackets, is equal to 0. Now we have to solve these two separately equations. 3t is equal to 0, and inside of the bracket 3t squared minus 6t plus 2 is equal to 0. So when we solve these equations, we have t is 0, t is 3 plus square root of 3 over 3, and t is 3 minus square root of 3 over 3. They are roots of these functions. So in these roots, it will be equal to 0. So we call them roots of this function. So the next terms are domain and range of the function. One of the more important ideas about function is that of the domain and range of the function. In simplest term, the domain of the function is the set of all values that can be plugged into a function and have the function exist and have a real number for a value. So for the domain, we need avoided division by 0, square root, negative numbers, logarithms of 0, and logarithms of negative numbers. The range of the function is simply the set of all possible values that a function can take. The next example, example number 4. Find the domain and range of each of the following functions. So how can we find the domain and range of the functions? Let's consider the solution. A1. F of x is equal to 5x minus 3. We know that this is a line. This is the function of line kx plus b. And it's not horizontal line. So how we can find now range? If you remember the graph of this function, so 5x minus 3, it will be a straight line, and range will be from minus infinity till plus infinity. So, and the domain is also the same, from minus infinity till plus infinity. We don't have any spatially special values for x. So this is polynomial. That's why it will be the domain will be minus from minus infinity till plus infinity, and y also takes the values from minus infinity till plus infinity. Range, it is the values which takes y. The domain, it's values which takes x. Okay, b1, g of t is equal to 4 minus 7t. This is square root, and we know that square roots are always positive or 0. It is greater than or equal to 0. We know then that the range will be from 0 till plus infinity. So gt maybe takes values from 0 till plus infinity. However, we have square root. So to find domain, we have we should solve the inequality 4 minus 7t greater than or equal 0. Here, after solving, we have the answer t is less than 4 over 7. It means the domain is this set of these values from minus infinity till 4 over 7. So the solution of this inequality. Again, answer is minus infinity till 4 over 7. Next one, C1. H of x is equal to this function minus 2x squared plus 12x plus 5. This is quadratic function, and it's polynomial. That's why the domain is all real numbers, or from minus infinity to plus infinity. So now, how do you find the range of this function? So to find the range of this function, we should remember from algebra class the graph of the parabola. So here the coefficient of x squared is negative. That's why the vertex goes down. I mean this it is opens down, and vertex will be the highest point on the graph. Even though the vertex, we can then get the range. The vertex is by the formula b over minus b over 2a. So in this case, b is 12, a is minus 2, and x the value of x is 3 in vertex. Y is equal to h of 3. Instead of x, we should put 3. And the answer is 23. So the coordinate of our vertex is 3 and 23. It means, however, the vertex is the highest point on the graph. So y takes the values from minus infinity till 23. This is range of our function. The next one, z1. F of z is equal to z minus 6 minus 3. So this function contains an absolute value, and we know that absolute value will be either positive or 0. In this case, the absolute value will be 0 if z is equal to 6. And so the absolute value portion of this function will always be greater than or equal to 0. We are subtracting 3 from the absolute value portion, and so we know that the range will be from minus 3 till plus infinity. Again, however, this one is greater than or equal to 0. The less value of f of z, it is minus 3. From minus 3 till plus infinity. So domain is here all real numbers from minus infinity till plus infinity. So next one, g of x is 8. What can we say here about range and domain? Exactly. The range is 8 just because it is line goes through the point 8 parallel to the x o x. So this is just 8 and the range is equal to 8, that's why. And the domain is all real numbers. Example number 5. Find the domain of each of the following functions we have in a fraction. So how can we find here domain of this fraction? You know, it's you cannot divide by 0. It's impossible division by 0. So we should take all values where our fraction is equal to 0. So in this case, when we equating this denominator to 0, we have 2 points, minus 3 and 5. So this is zeros of denominator, minus 3 and 5. So there are only values of x that we need to avoid, and so the domain is all real numbers except minus 3 and 5. We should accept them because of we cannot divide by 0. In other points, it's okay. So all real numbers except minus 3 and 5. This is answer of our example. B1, g of t is equal to square root of 6 plus t minus t squared. In this case, we need to avoid square roots of negative numbers and so need to require that it's always greater than and equal to 0. That's why when we multiply both sides of our equality to minus 1, so you should remember to switch the direction of the inequality, and we have the following factorization: t minus 3 t plus 2 of this one. This is quadratic inequality. So we can see in the graph also this polynomial quadratic, so greater 0 when it's greater than minus 2 and when it's greater than 3. Between minus 2 and 3 it's less than 0. That's why we need to take less than or equal 0. So the domain is from minus 2 till 3, between minus 2 and 3, or segment minus 2, 3. C1, h of x is equal to x over x squared minus 9. So in square root, how can you find here domain? Here the denominator is in square root and we should accept the points when it's equal to 0. However, we cannot divide by 0. It's impossible. So on the other hand, we Here we have square root. That's why we need to solve inequality x squared minus 2 strictly greater than 0, not equal. Here, just strictly greater, because of we have this expression in denominator. So when we solve this inequality, this again quadratic inequality, answer, we get answer from minus infinity till minus 3 and from 3 till plus infinity. So this is domain of our function. The next topic that we need to discuss here is that the function composition. The function composition of f of x and g of x, it is we call this one is composition of two functions. So we should plug the second function into the first function. Example, given f of x and g of x, find each of the following. Solution. A1, f composition of g in the value of 5. In this case, we have got a number instead of an x, but it works in exactly the same way. F of g of 5. Firstly, we should find g of 5. G of 5 is equal to 1 minus 100. It is minus 99. So now f minus 99 we should find. We should put just instead of x minus 99. After computing this expression, we have the answer 29,512. This is composition of f and g, two functions. The next one, b1, f of f and g, composition of f and g of x. So it means f of g of x. So instead of x, we should put g of x. And our g of x, it is 1 minus 20x again. So here in function f of x, here we should put instead of each x, g of x. And we have answer 3. 1 minus 20x squared and minus 1 minus 20x plus 10. After simplifying, we have the following answer. So compare this answer to the next part and note that answers are not the same. The order in which the functions are listed is very important. For example, if we find g of f of x, what we have? G, and now instead of f of x, we should put f of x now, this expression, quadratic polynomial instead of x. And we get answer 1 minus 23x squared minus x plus 10. After simplifying, we have minus 60x squared plus 20x minus 199. So order is important in composition. Example number 7. Given f of x and g of x is equal to 1 over 3x plus 2 over 3. Find each of the following. So we should find out f composition g and g composition of f. A1, f of g of x. So again, just we should put instead of x our g of x. So 3 multiplied by 1 over 3x plus 2 over 3 minus 2. If we open the brackets, we have the following answer: x plus 2 and minus 2. So it's equal to x. This is f of g of x. Now, next one, g of f of x. So it means in function g, instead of x, we should put what? F of x. G of 3x minus 2, it's equal to 1 over 3. 3x minus 2 plus 2 over 3. When we simplify this expression, we have the answer x. Now, we get exactly the same answers when we compute f of g and g of f. So, in fact, the answers was very simple. You can see here, they are equal to x. So, why we have same answers to this question? We will answer in the next part of our lesson. So the next topic is inverse functions. So functions pairs that exhibit this behavior. So when f of g of x is equal to g of f of x are called inverse functions. Let's give firstly one-to-one functions. A function is called one-to-one if no two values of x produce the same y. Mathematically, f of x1 is not equal to f of x2 whenever x1 is not equal to x2. So, a function is one-to-one if whenever we put in different values into the function, we get different function values. So now, finding the inverse of a function. Given the function f of x, we want to find the inverse function f minus 1 of x. This is the notion of inverse function. It's not power. This is f minus 1. It is the notion of the inverse function. First, replace f of x with y. This is done to make the rest of the process easier. The next step, replace every x with y and every y with x. So we should change x to y, y to x. Then solve the equation from the second step for y. First one, replace y with f minus 1x because this is now we get the inverse function. And fifth one, so uh, this is additional one. So if we want, we can verify our answer. So f composition f minus 1 of x is x, and f minus 1 composition of f, it is equal to x, are both true. So we can verify our work. Let's consider first example. Given f of x is equal to 3x minus 2, find f minus 1x. Solution. So let's firstly replace f of x with y. Next, replace all x with y and all y's with x. So we have x is 3y minus 2. Now solve for y. So x plus 2 is 3y. After that, we have the following one. X over 3 plus 2 over 3 is equal to y. Finally, we can replace y with f minus 1x. This one we call inverse function of this function. So again, I repeat, so we should change all x to y, all y's with x, and solve our equation for y, and we get inverse function. Solve for y. This is important part of finding inverse function. Now we need to verify this result. So f of f minus 1 of x is equal to f x plus 3 plus 2 over 3. Here, instead of x, we can put our inverse function. And we get answer x. So it means this is inverse, exactly inverse function of our function. We verified our result. Example number 2. Given g of x, which is equal to x minus 3, square root of x minus 3. Find g minus 1 of x. Solution. The fact that we are using g of x instead of f of x doesn't change how the process works. Here, the first few steps just change y to x and x to y. No, now to solve for y, we will need to first square both sides and then proceed as normal. When we're squaring both sides of our equality, we have the following function. X squared plus 3 is equal to y. This inverse is then g minus 1x is equal to x squared plus 3. This is inverse function of our function, square root of x minus 3. So you can see the graphs of the example 1 and example 2. Here, f of x, this is the graph of the function f of x. This one is the graph of the function f minus 1x. Here we have basic trace of the first quadrant, y is equal to x. In the second one, example number 2, we have this one is g of x, square root of the function this, and g minus 1 of x. Remark, in both cases, we can see that the graph of the inverse is a reflection of the actual function about the line y is equal to x. You can see they are reflections about this line. In this, the same, they are reflections. So this will always be the case with the graphs of a function and its inverse. So inverse function will be reflection of the actual function about the line. This is important. Okay, example number 3. Given h of x is equal to x plus 4 over 2x minus 5, find inverse function of to this function. So again, we can change all y's with x and all x's with y, and then solve this equation with respect to y. So we can multiply to the right side, denominator of our fraction, and after that, when we solve with respect to y, we get this answer. So 4 plus 5x over 2x minus 1. So this is inverse function to our function. So again, I will remind you. So to find inverse function, firstly, just we should change all y's to x and all x with y's, and then solve the equation, the new equation with respect to y, and we have the inverse function to the given function. Thank you for your attention.